And now I want to look at the other change we made so far in this lesson. Let's take a look at the application.html.erb file, this layout file. Just a reminder of where this lives. This is in app views layouts. And so we've got this style sheet link tag. Now, we've seen this before. This is embedded Ruby. And so what this is doing is inserting the results of this expression. Now, this here, the style sheet link tag, is just a function defined by Rails. And what it does is it takes in a string as an argument, which in this case is blueprint/green. And this is the name of the cascading style sheet. So if we go to public style sheets blueprint, you can see that there's a style sheet called screen.css. In fact, we can even take a quick look at it. So in this context, blueprint/screen is the screen.css file. Now you might notice that there's no .css here. The style sheet link tag will add that automatically. It will actually work if you put it on, but you can omit it. So that's the first argument, but what is this thing? What is this guy here? And we see it down here again. Media, I don't even know how people usually read this. Media goes to screen, media equals screen, media is screen. There's this strange equals greater than sign character. So what this thing is here is a hash. And so this is an indication that there are some data types in Ruby that we barely know anything about. So this next section is going to discuss some of the more useful data types in Ruby. We'll start with one of the most useful data types in Ruby called an array. Now, we've seen arrays before in the context of the demo app when we looked at the microposts belonging to a particular user. But arrays are a general data type available in Ruby, and let's get a sense of what some of their properties are. So I like to start with a string here. This is a nice illustration of a particularly useful method on strings. Let's do foo space bar, and then I'm going to put in a bunch of spaces, and then baz. And I'm going to split this. And by default, what this will do is split on white space. So what this does is it takes the string and it splits it into its component parts, removing the white space surrounding each string. So here we've got foo bar baz. In fact, we can put in another character. We can put in a tab character. Does the same thing. We can put in a new line. So it just gets rid of any sort of white space. That's very convenient. So this is an array, this foo bar baz, this guy. This is an array of strings, as indicated by these square brackets. I should mention that split works on white space by default, but in fact you can split on anything else. So if I did foo with an x character, you can actually do, like, say, triple x, foo bar triple x baz triple x, and split on triple x. It's the same thing. So without an argument, splits on white space. It's really useful, actually, because it splits on something that is kind of hard to describe. It's not a particular character or string. It's an idea of white space. Now, in this case, we've got an array of strings, but arrays can have pretty much anything inside them. Arrays are general containers. Let's define an array that's equal to a list of numbers, 42, 8, 17. And now let's see how we can pull out elements of this array. Now, arrays in Ruby, like the arrays in virtually every modern programming language, are zero offset, which means that the 0th element, which is also sometimes called the first element, is equal to the first element in the array. So here are 42, and you can also do 1, 2, and you can even do -1, which wraps around from the back of the array. If you just type an array at the prompt, then it evaluates as itself. And there are some aliases for common elements in the array. So for example, you can get the first part just by a.first, and you can do a.last as well. And now you can also do a.second in this case. This is actually not currently part of Ruby. This is added by Rails. But some of the previous extensions to Ruby defined by Rails have actually been incorporated into Ruby by now. So who knows, at some future date, this might be part of Ruby. Ruby is so malleable, as we'll see later in this lesson, that you can actually open up the default Ruby classes and add methods to them so that it looks just like it's a native method. There's no way to distinguish between a method that came with Ruby and a method that's been added. So the second method on arrays is like that. It looks just like a native part of the Ruby language. As is the case with strings, arrays respond to a large variety of methods, including some of the same methods. So for example, a.length returns the length of the array just as a.length, or just as s.length would return the length of a string. You can also do a.empty. This should be false. Indeed it is. Arrays can also be compared to each other. So suppose we were to say a double equals 42, 8, 17. This is true, but we can't use more general comparisons. A greater than or equal to doesn't make any sense for an array. But this does make sense for integers, of course. If we were to say x equals a dot length, that's equal to 3, we could say x double equals 3, which is usually just read as x equals 3. That's true, and x greater than or equal to 3, it's also true. X greater than 3, false. X less than 3, false, and so on. There's one more with mentioning x not equal to 17. This is true. So let's look at some of the other methods available on arrays. We can go to the Ruby API for this. So this may be a little intimidating at this stage, but you can learn an awful lot about Ruby data structures by going to the API and just reading through the different methods available on the different data structures. So in this case, we've got an array. Let's look at some of the things here. We've got array. What are some fun ones? Here's a useful one, array.sort. And so these are great examples. You can just look through these, and this won't teach you very much about how to structure a large Ruby application. But you don't have to know how to do that because we're writing Rails applications in this tutorial and not Ruby applications per se. I will have some recommendations for further resources at the end of this lesson. So a.sort will sort the elements, and in this case this is a list of strings, but we can also sort an array of integers. Here's our array. Array.sort. This sorts the array into ascending order. Now let's take a look at what the array is though. Notice that it didn't actually change the array. What happened here is that a.sort evaluated as the sorted array, but it didn't actually change the array. There is a way to change the array itself though by saying a.sort bang. This exclamation point, the bang here, is a hint that the method does something special. In this case, what it does is it mutates the array, and in plain Ruby, the exclamation point almost always indicates some sort of modification of the object it's being called on. So a.sort bang, that evaluates as a.sort, but now if you look at a, it has in fact been mutated. And this pattern continues. You can do a.reverse, so that reversed the array, but of course the array wasn't changed. If you do a.reverse bang, it reverses the array and it mutates it. And finally, one of my favorite operations on arrays is the shuffle method. A.shuffle. It just puts it in a random order. And so this is a fun time to introduce a new data type, which is called a range. Let's consider a range 1 up to 52. Let's turn this into an array. 1.52.2a. Remember we saw before a toS method, which converted its object into a string. This converts the object into an array, but this isn't quite going to work. So the reason that didn't work, you can see. So you can see why that didn't work. It says no method error. Undefined method 2a for 52 fixnum. So fixnum is the data type for an integer, essentially a small integer. If the integer is too big, it becomes a big num. But you can just think of this as an integer. And so what's happening here is that we're seeing that there's a binding rule in Ruby. The binding rule is that if you have something dot a method, that this dot is bound more tightly to the 52 than this double dot is bound to the 52 on the other side. So what's happening here is we want it to be a range converted to an array, but it's actually calling the 2a method on the integer, and there is no such method on integer. So let's put this in parentheses to group it properly. So here's our 1 up to 52, 2a. And you might have been able to guess the reason I chose this particular number with respect to the shuffle method. If we shuffle this, we shuffle it, then this is the result of, say, shuffling a deck of cards. There are lots more methods on arrays that you can read about at the API. Let's take a look at one of the more important ones, which is this. This is a push operator. It appends to the end of an array. So let's take a look at what that does. Reminder what A is. So if we do this operator, see, this is what this is, this double less than sign, we can, say, put another number on at the end. And one of the cool things about Ruby is that you can mix types. So you don't have to put an integer in. You can put in, say, a string. You can even put in, say, a range. So we are into the same problem there. By now you probably can figure out what to do. There we go. So a range is just its own little object. If we do a dot last dot 2a, see if you can guess what this will be. It's just 1 up to 5 converted to an array. And so you can pretty much put anything into an array. You can even put another array. This is a nice syntax for an array of strings. %w and then foo bar baz. There's one array nested inside another array. So you might have noticed at this point that arrays and ranges have something in common. I mean, it's so easy to convert from one to the other. Say, oops, 2a. And one of the most important aspects of both arrays and ranges is that they effectively consist of a list of elements. And one of the most common things to do with such a data type, or such a data structure, is to iterate through each element in turn. This is a property known as enumerability. And a data type that supports this idea is known as enumerable. So let me type that out. This is an unusual word. And if I hit return, you can see that there's not even an error or anything. That's because enumerable is already defined in the context of this console. Enumerable is a Ruby module that has functionality associated with this idea of going through each element in turn. Now, my use of the term each is actually a hint about how enumerability works. The core of enumerability is the definition of an each method for the object that gives access to each element in turn. And we'll see that not only arrays and ranges, but also hashes and a lot of the data types specific to Rails applications support an each method, which is often convenient because a lot of the kinds of things you want to do in web applications involves going through a bunch of elements one at a time. So let's take a look at a range. 1 up to 5 dot each. Now, you would never do this in isolation, but I just want to give you a sense of the connection between this object and the notion of enumerability. So what you actually do with this in practice is you iterate through it. This is essentially the way that you would do looping in Ruby. So if you wanted to do something from 1 up to 5, suppose you wanted to do the same thing. Say you want to print out the particular value. So you can do 1 up to 5 each, and then an open curly brace. And this, what we're defining now, is a block. And this particular kind of block requires one variable, which in this case is, I'm just using letter I, inside of vertical bars. Let's print it out. Put s, let's do something interesting with it. Let's introduce a new method. This is 2 to the I. That double asterisk character is exponentiation. So see if you can guess what this will be. There we go. So 2, 4, 8, 16, 32, which is 2 to the each of these powers. And then it evaluates as the object itself. You almost never care about what the evaluation is. In this case, it's just the side effect that matters. So with each, usually you care about the side effect. But there is a way to get an array of all of these values. It's very convenient. Now, of course, you could define like an empty array, and then we just saw how to push to it. So you could, inside this block, push to an array. So let's try that. Let's say A is equal to the empty array. And then we could say 1 up to 5 dot each I. And then we can append. Remember how to append. It's A with this double less than sign. So we push onto the array 2 to the I. Now let's see what A is. So that's what we wanted. But this is a cumbersome way of doing this. There's a much nicer way in Ruby. There's a method called map. What map does is it's like each, except what it does is instead of returning the original object, it returns an array. So this is 2 to the I. So this is just going to go through 1 up to 5 and replace each of these elements with this thing, with 2 to the I. So that's the same thing, but it's more compact. If you've done much functional programming before, you'll likely recognize this map method. Just as an aside for those of you who are more advanced, you may be familiar with the idea of accumulate. It has various names in different languages. In Ruby, accumulate is called inject. So that's beyond the scope of this tutorial, but I encourage you to look up inject in the Ruby API. Now there's something else to know about these things that are being passed as arguments to the each method in this case and the map method here. So this is an argument. It doesn't look like it maybe, but this is being passed to this expression. This thing is a block, this stuff inside the curly braces. There's a second notation for blocks, which is, in this case, 1 dot dot 5 dot, say, just do map, and then you can say do I. And let's just do 2 to the I, and then end. In this case, map accepts a block with one variable, one local variable inside the block. But you don't necessarily need a variable. Sometimes no variable is required. So for example, if you wanted to say Beetlejuice 3 times, you could do 3 dot times do put s Beetlejuice. End. And you can see that there's no argument here at all. For what it's worth, these things, these blocks, in computer science are known as closures, although I've never known anyone to understand what a block is by making reference to closures. If you know what a closure is, you probably already figured out this is a closure. The only way to understand blocks, in my experience, is just to see it lots of times. There's no succinct way to explain exactly what a block is, but eventually you get used to it and you realize there's not anything inherently mysterious about them. They just are defined by a bunch of properties. And one of the things you'll learn is that blocks are everywhere in Ruby, so you'll just become accustomed to them and they won't be a big deal. In fact, let's take a look at our source code. Let's take a look at the gem file. So you haven't seen this in a while, but now this gem file has a little bit more structure to it because you can see what's going on here. There's a group method. This is something you can use inside of Bundler. You don't necessarily need to know how this works. I don't know how it works. But you can see here we've got do end. So that tells you that whatever this group thing is, it's taking an argument, and we're about to cover what this guy is. And then it takes a block. So this do end is a block. And if you look through the source code for a Rails application, you'll often find that blocks are everywhere. Let's look at another one. This is the pages controller spec. All of these are blocks. It should be successful do, and then this stuff is inside of a block. In fact, describe name with a string and then do. This is also inside of a block. So this whole in fact, you may recall that I referred to this as a block of code. That wasn't an accident. It's actually a Ruby block. Before we move on, I want to show you that it's not only ranges that respond to these map methods, say, with the block as an argument, but you can also use arrays. So let's go back to this very useful way of defining an array of strings, A, B, C. This saves typing a lot of quote characters. So just remember what this is. Oops, it was a mistake, wasn't it? Oh, I accidentally showed you something really useful. I actually usually use parentheses. But if you do A, B, C, and with parentheses percent parenthesis, then stuff, and close parenthesis. This is actually another way to do a double-quoted string, which is really nice if you want to put double-quoted strings inside it. See if you can guess what this will be. So what we're doing here is this is single quote string backslash quote. You have to escape out the quote. If you're inside a double-quoted string, you have to escape out any other double quotes, because otherwise it would think that it's the end of the string. And so sometimes if you want to define a string that has double-quoted strings inside it, then you can use this percent open parenthesis, close parenthesis. Then you might say, well, why not just use a single-quoted string? And the answer is because if you use a single-quoted string, this works. But what if you want to do something like this? You want to interpolate something, first name. And now it doesn't actually do the interpolation. So if you do percent open parenthesis and then the stuff inside here, it actually interpolates what first name is. So that was a happy accident. But what we really want here is percent W, A, B, C. And now let's take a look at something you can do with this. It's map to each character. Or it's actually each string. It really should be each string. Let's do the uppercase version of the string. This is the uppercase, so strings can respond to the uppercase method. So see if you can guess what this will be. So this is just the array. Instead of A, B, C as strings, this is capital A, capital B, capital C. In a situation where you have a block being passed to a method, where all that the block consists of is some other method being called on that variable, in this case, uppercase being called on string, is so common that there's an alias for it. And let me show this to you, because it's quite common in Rails code. I guarantee you'll come across it if you look at a lot of Rails projects. So let's look at abc.map. Now what we really want to do is just apply uppercase to each of these guys in turn and return an array consisting of the capitalized versions of these. So the way to do this is with open parenthesis, ampersand, colon, uppercase. And there we go. So it's a more compact way of writing the same thing. Now you may be wondering what the heck this thing is, and you may also have noticed that we keep seeing this construction, colon and then something. Here we've got colon and then something. It seems like pretty much everywhere you look, there's a colon and then something. So it's about time that we understood what this sort of thing is. You know, we can get an understanding of what these weird colon things are by looking at an example first with a string. Let's look at foo as a string. Let's call class on it. This will tell us what class this is. So unsurprisingly, foo is of class string. Now let's take a look at colon foo. So colon foo is a symbol. Now strings and symbols are very similar to each other in that they can both be used as labels for things. And the most common context in which they're used as labels is in the context of a hash. So let's take a look at what a hash is. Hashes and symbols go hand in glove, especially in Rails applications. So let's define an empty hash. I'm going to call it user. So an empty hash is open curly brace, close curly brace. If you do user.class, you see that it's a hash. Now I want to let you know that these curly braces have nothing to do with the curly braces we just saw in the context of blocks. They're totally unrelated, and yes, this can be confusing, but that's the way it is. So what is a hash? Well, hashes are essentially like arrays, except instead of having integers as their keys, they can have more general things. So let's look back at our array A. So A of 0 is 2, A of 1 is 4. What about A of foo? Can't convert string into integer. So arrays are indexed by integers. But hashes are a more general kind of data type. We can do user, and we can assign, say, user of first name with a string. We can set this equal to Michael. We can do user of last name. And now we can see what user is. And now let's just call user of first name. So this is just like that array access, except instead of using an integer, we're using a string. You can even do something like user of 17 equals hello. So this just looks like an array. There is one really important difference between arrays and hashes, though, which is that arrays have a particular order. Arrays are 0 up to the length of the array minus 1 in terms of the index. But hashes don't have any intrinsic notion of order. I'm told that in Ruby 1.9 they are guaranteed to preserve the order according to when things were added, but it would be unwise ever to rely on this. Hashes fundamentally don't have a notion of what the order is. What hashes are is key-value pairs. The order isn't important, but what is important is that for any key, say first name, there's a corresponding value, in this case Michael. Now you can also build up hashes literally rather than one element at a time, like this. User equals open curly brace, first name, and we see this equals greater than sign. We've seen it in the output before, but now this is the first time we're typing it. Should probably capitalize my last name. Let me just note that there are spaces here after the curly braces, and that's just conventional. I don't know why people do that, but I just follow convention. The output of the console is different. It gets rid of those spaces. So this is a literal definition. It's equivalent to what we did before. But in this context, especially, and in general in Rails applications, you almost never use strings as keys. Instead, you use symbols. Let's look at this. User, this is the conventional way to define a user. First underscore name, and this is the way you would define a user conventionally in terms of key-value pairs. So instead of using strings as keys, this hash uses symbols as keys. And if you look back here, you can see, for example, this strongly resembles a hash in terms of this is a key-value pair with this equals greater than sign. And if you look back at our example of the style sheet, this also looks very much like a key-value pair. So let's talk a little bit about what these symbols are. Symbols can be a little confusing because they don't exist in most computer programming languages. Most languages would use a string in this context, but strings aren't as good as symbols for this use. Strings are really just actual strings of characters. So for example, if you do name.length, this has length 4, it has structure. And so if you were to say, for example, s equals name, and you were to compare s to, say, is s equal to, use single quotes, is s equal to name, that's true. So the way this is being done, the way this comparison is being done, is comparing each character of the string. So it's saying, for each character in s, is it equal to each character in name? In other words, is the first character here, n is the second one, a. To find out if these two things are equal, you actually have to go through each character in the string, whereas something like colon name is not a string, and if you were, say, to call length on it, so you may find this surprising, and this surprised me, because in previous versions of Ruby, this actually raised a no-method error, but in Ruby 1.9, apparently symbols now keep track of their own length. But we can see that symbols are different from strings another way by doing, say, s.split. Let's just do it, the literal string. Name.split. Let's split it on an empty string. This will split it into its component characters. And you can see that the symbol name cannot be so split. We get a no-method error. So this indicates that the name here is actually a list of characters all smushed together, whereas the name as a symbol is not. And this is important because symbols can be compared all at once. They don't have to be compared one character at a time, which makes them particularly good for use in a data structure that requires fast lookup, such as, for example, a hash. If you wanted to do user of colon first underscore name, this is an efficient operation because in order to find this element, you have to look through the hash and compare this key to all of the keys in the hash. And since that lookup is fast with symbols, symbols make ideal hash keys. And in fact, hash keys in Rails are almost exclusively symbols. Now, like ranges and arrays, hashes are enumerable, which means you can iterate through them. Let's consider another example. Let's look at a flash hash. This is a hash called flash, and we're going to give it a couple symbols. Success, it worked. Error, it failed. And now we can iterate through it by saying flash.each do. Now remember, with an array or with a range, we would have just done one variable here. We would have said I, say. That's what we did before. But in this case, each element in a hash is a key value pair. It's not just a single thing. And so it's convenient to use two variables, key, often called key value. And now let's say put s key dot inspect has value dot inspect. Key success has value, it worked. Key error has value, it failed. And then it returns, it evaluates the hash. Again, with this sort of .each construction, you don't really care what its return value is. It's used, in this case, mainly for its side effects. Now, notice that I called this inspect method on the key and the value. And the reason I did that is very simple. Let's take a look at what happens if you interpolate, say, success as a symbol into a string. So what happens there is that, remember we saw the 2s method. This interpolation is calling 2s on a string. And you can it's calling 2s on a symbol. And you can convert a symbol into a string. But in this case, I actually wanted to output something that looked like a symbol. So you can see how that works. Inspect is a method that lets you inspect what a particular object looks like, and it's just the literal value in this case. So we can do this. Oops. And we can also put s it. In this case, you see that it's colon success. Whereas if you were just to put s this, now it puts the string. This is really useful to output the inspect version of something. So for example, you can do put s. Suppose you were to put s this 1, 7, 18. That's probably not what you want. If you want to output an array, it's more convenient to do this. This actually shows you what the array is. And this is so common that there's actually an alias for it in the console, which is to do p. So at this point, we're ready to understand this stylesheet link tag. We now know that there's a single argument here, a first argument, but there's a second argument to this function, and we'll see concrete examples of this later on in the tutorial. But this second argument is an options hash. This is a key value pair with a symbol media and a string screen. But there's one thing you may wonder about, which is why is there not an open curly brace and a closed curly brace? And you may also wonder why this function call doesn't have parentheses around it. And the answer is it can. In Ruby, they're optional. Let's take a look at this. This works exactly the same. Nothing changed. So these two things are the same. And in the context of a final option or a final argument to a method, you can leave off the curly braces in a hash. And you can also leave off the parentheses in a Ruby function call. So one of the style questions you have to answer in Rails programming is, when do you leave the parentheses off and when do you put them on? And the answer is, you just have to develop a personal style for it. And in this context, I think it's more common to leave them off, and sometimes you'll see that I'll put them on. This is our last look at the style sheets for a while. Before leaving it, let's just take a quick look at the source of this page. So we see here that there's in the head of the page, there's a link with an href to the screen.css, media equals screen, and then there's some other stuff that gets put in automatically by the style sheet link tag. You might also notice this number, this question mark number. I'm pretty sure that's there to get browsers to reload the file. Sometimes they'll cache it, and if it changes, you want them to reload it. This number here is just to tell browsers when the file has changed and to get them to expire their cache and download the more recent file. So far in this tutorial, we've talked an awful lot about Ruby classes without ever talking explicitly about what they are. We're finally going to remedy that in this section. So let's take a look at an example of a Ruby object, say s equals foobar. And we've done this before so far in this console session. Let's do s.class. So this is class string. So this gives us a hint that a class is just a way of describing an abstract quality of a bunch of objects. So any particular string is a concrete object, but all strings belong to the string class. In this case, when we wrote s equals foobar in single quotes, we constructed an object which is an instance of the string class. This is what's known as a constructor, and in this case it's an implicit constructor because we just use literal double quotes to make the string. But you can actually invoke the constructor explicitly as follows. We could have said s equals string.new and then passed it a literal string. You can't get away from that. So you can see that s is the same as it was before. In this case, we've explicitly invoked the new method on the string class, and that's the universal Ruby method for constructing a new object corresponding to that particular class. We can do the same thing with an array. We can say a equals array.new and then pass in a literal array. We can also create a new hash, say h equals hash.new. But in this case, we don't initialize it with a literal hash. That's not what the hash.new method takes. You can actually leave it off. You can see, though, that there's a literal empty hash, open brace, close brace. And you can take a look at some of its values. Let's look at h of foo. You can see that if the key is undefined, which it certainly is for an empty hash, the return value is simply nil because it doesn't exist. There is no such value corresponding to key foo. But you can actually define a hash a different way. The argument of hash.new is the default value. In this case, h of foo, see if you can guess it, would be 0. So this is sometimes useful if you want a default value other than nil.